Let's start here. So we're going to learn about partial fractions. Super fun stuff here. It's like the complete opposite of adding fractions with common denominators. You're actually trying to take a fraction and pull it apart. Okay, so usually we have like a problem like this, where we have like 3 over x plus 4, and then plus 2 over x plus 3, and then we get some common denominators, and then we do all this fun stuff, and then kablamo. That's our answer. This is what we did a couple classes ago. This would be your problem. This would be your answer. Now we're going to go backwards. This is your problem, and this is your answer. That's all we're doing. Start here, go to here. There's two methods. There's the working through the entire thing method, which I'll do with you first, and then there's a shortcut. I call it the zero method because it's a really big shortcut. But there are 4 cases to deal with partial fractions, and I'll kind of just hit each one as we go. So if you want to read that whole thing on your own time, go for it. If not, let's just do this. I know it looks like a lot of work. It's really not. So case 1. This means that we have non-repeated linear factors. This means that when you factor something on the bottom, it's not repeating. Okay? So first things first is we have to factor if on the bottom. So how do I factor the bottom here? It's 2x and x, and it's 1 and 1, because those are the only options we have. Just what's my signage? Plus 2 minus 1 gives me a plus x. You can't see anything? Do you need to zoom in? You write small. Alright, and this is case 1 because the denominator factors, what the heck is the thing? Because the denominator factors, oh, okay, got it, into linear factors. Is this big enough now? Okay. So now we have this. We have 5x minus 4 all over 2x minus 1 x plus 1. And since there's 2 factors on the bottoms, how many fractions do I need then? So I'm going to call it a over 2x minus 1 plus b over x plus 1. I want to solve for a and for b, and then boom, final answer. Okay? Quiet over there. So to do that, I need to multiply by this denominator on every single term I have. So if I were to multiply this first one by 2x minus 1 and x plus 1, what happens to the denominator here? It's going to cancel out and go away. If I do 2x minus 1, x plus 1 to the a one, which one goes away? The 2x minus 1 is going to go away. If I multiply this one, the b, by 2x minus 1, x plus 1, what goes away? There we go. So let's go ahead and rewrite this now. So this is going to become 5x minus 4 equals a times x plus 1 plus b 2x minus 1. All I did was some math, multiplying. That's all I did. Are we all with me so far? Because right now we're good. It's about to take a turn for the worse very soon, because I'm going to do something that you all have seen before, but you're going to go, whoa. Did you just do some voodoo magic over there? I'm going to say, no, it's just math. Let's distribute here. So to distribute, I'm going to have ax plus a plus, I'm going to say b times 2x. I'm going to leave it that way, and I'll kind of show you why, minus b. I want to organize this so that my x's are in front and my constants are in the back. So I'm going to do ax plus b times 2x plus a minus b. All I did was rearrange. Okay? And this gives me a 5x minus 4. Okay, let's look at my x's only. Okay? What's my x coefficient on the left side? It's a 5. So do you agree with me that 5 is equal to, what's the x coefficient for a? It's a. That's it. What's the x coefficient for the b? 2b. Let's do the negative 4 now. What's the a minus b. This is a systems of equations. You have seen this before in your life. You can solve this two ways. You can either do substitution, which means you solve for either a or b, and then plug it in and then solve, or you can do elimination. That's when you just multiply one of these by a number, just either the top one or the bottom one, and then add them together, and then you can start to solve stuff that way. It does not matter how we do this. Which way do you want to tackle this? Elimination? Okay, so we want to multiply everything by? 2. The bottom one by 2? That's not the only option. What else could you multiply it by if you wanted to? A negative 1. So we're going to get, the bottom one becomes negative 8 equals 2a minus 2b. Add these together, and what am I going to get? Sharing the top one and the bottom one. So what does that equal? Negative 1. I'm trying to see the way they taught it in the past, and I can't follow it. I have no clue what they're doing.
Is this the voodoo magic?
No, like this is no.
Okay.
I mean, like yes, going from blue to red, that could be the voodoo magic for some of you. Okay, once I have that a is negative 1, I'm going to go ahead and solve for b. Yeah, what the heck are they doing in this one? I have no clue. Okay, so plug into the top one. So I'm going to get 5 equals negative 1 plus 2b.
Oh, so 3.
So we're going to get b to equal 3. Can I write that down, or do I need to show that work?
No, write it down.
So now, I know that a is negative 1 and b is 3. So my final answer is going to be what? A is equal to negative 1. So I'm going to get negative 1a. So for a, and the denominator in the bottom was 2x minus 1. And then it was x plus 1 for the b one. And then plus 3 over x plus 1. And that's what you get. It's the final answer. So it's actually extremely useful in calculus, because there's something called antiderivatives, and you can't take the antiderivative of something like this, but you can take the antiderivative of simple fractions. So this is my final answer. For some reason, the notes key has a different answer. I'm going to say that person didn't know what the heck they were doing, because I didn't make any bad errors, did I? That looks right. Okay. You can always check it too.
We just learned this. How are we going to know this?
Well, I mean like math errors, like 1 plus 1 is 3. The process is correct. That's one way to do it. Another way to do it, and this is the way that I usually do it, but it only works 90% of the time. So if this worked all the time, I would just like to do it. When you get to this step right here, set one of the factors equal to 0. So if you set this first factor equal to 0, what do you get? So plug in a negative 1 for x. So if you were to do that, you'd plug in a negative 1 there, there, and there. When you do that, what happens to the a? It becomes 0. goes away, right? And then, so I was just going to show you. So if I let x equal -1, in this case for right here, this would become 5 times -1, which is -5 minus 4, which is -9. So I would get -9 equals, we just said that a goes away because I picked -1 on purpose. And then what's 2 times -1? -2 minus 1 is, so I'm going to get -3b. And then what does b equal? I don't know, was that faster? Okay. Oh yeah, that's right here. What's that?
Why doesn't it always work? What's the situation?
So the situation where it's not going to work is if you have 3 terms, it'll work sometimes, like we have an A, B, and a C. But if we only have like x plus 1, and then the B term was like 2x minus 1, and then x plus 1, and then the C term was like 2x minus 1, we can't plug in zeros. We don't have enough factors to solve for A, B, and C. We don't have enough factors to solve for actually just one of them, or actually no, 2 of them for that case. So if you have as many factors as you do unknowns, then you're fine. Okay, and then you can do the same thing. So what would you set equal to 0 for this one to get rid of B? So set that equal to 0, you get 1/2. And then so when you do this one, you're going to get 5/2 minus 4, which is kind of annoying, but is it -3/2? No yawning, this is exciting. And then you're going to get 1/2 plus 1, which is 3/2 A. So 3/2 A. Solve for A, and you're going to get A equals -1. And there you go. I have no clue what this person did on the keynotes. I should make that your homework assignment. Find the error that they made, because they did something terrible. Alright, and that's it. 2 different ways. I don't care which way you do it. But, hey, let's move on to the next one. So this one's going to have repeated stuff on it. Okay, so let's go ahead and factor this, and don't go any further, because I want to show you what the heck is going on. Is that really it? Okay, so now, how many factors do I have? I have 2. I agree. And 1's repeating. This is what makes this case special. If you have a repeating, and it's kind of like written in here, but like very poorly. If you have a repeating factor, you have to write it as a single factor and as a double factor. This is what I mean by that. So, A over X, because X is one of our factors, plus B over X squared. That's the repeat. Okay, so if you have X squared, you have to do X, and you have to do 1 with X squared. Plus C, what's my other factor? X minus 2. So this will probably be one of those cases where that little trick I use might not work, because if you see here I have repeating factors. So again, if this was x to the 4th, let's just play pretend. If this was x to the 4th, I would have A over X, B over X squared, C over X cubed, D over X to the 4th, and then whatever else I have. So every time it repeats, you have to do the 1 power and then the 2 power. We don't go beyond repeating 2 times. At least I haven't seen it so far. Okay? So now, when I multiply everything by x squared, x minus 2, can I skip the step of like the, I don't know, the showing you step and just go right to the next one? So I multiply everything by x squared, x minus 2. I'm going to get x plus 1 equals, x cancels out, and so what's left over for the A? X minus 2. For the B, what cancels out? X squared cancels out, so I'm left with. And then for the C term, okay. So this one, my zeroing out's not going to work. So that's fine. The reason is, again, because I can plug in a 0 and a 2, but that's not going to eliminate everything I want. Let's just go do the method that we did before. So let's just distribute everything. So what's ax times x? Ax squared, ax times negative 2. I'll just do 2ax. I think it's fine if I do it that way. We're cool with that. Plus bx minus 2b, or not 2b. Okay. Let's organize it now. So on the right-hand side, I have x squareds, I have x's, and then I have constants. So let's organize it now. So I'm going to have ax squared plus cx squared minus 2ax plus bx minus 2b. Am I missing anything? Okay, let's go ahead and organize this. So for the x squareds, on the left-hand side, how many x squareds do I have? I have none. So I'm going to do this step in red. So I'm going to have 0, this is for the x squareds, equals, what's the coefficient of the first x squared? Coefficient of the next x squared. Okay, let's talk about the x's. What's the coefficient in front of x? 1 equals, in front of the first x is a, and then the next one is going to be b. And then the coefficient for the last one is 1. So 1 is equal to negative 2b. That's kind of nice because I can start solving everything through here. So when I have all this information, let's start solving. What's the first thing we can solve for? What does b equal? Boom. Now we can use this equation. So now I have 1 equals negative 2a plus negative 1/2. Let's go ahead and solve for a here. So when we do that, what do you want to do? Okay. I agree with that, but I see people's heads shaking. I want to make sure that we're kind of all squared away. Are we cool with where I am at step 2 right here? Everyone said yes. Are we cool with b equaling negative 1/2? Okay. So all I'm doing is I'm plugging this into there. That's all I'm doing. So here's this equation, plugging that b into there. I have to solve for this. This could have been on day 1 algebra review. This is actually a question that Algebra 1 kids can solve. I don't care how you solve it. There's 2 ways. You can either add that fraction over right away, or you can just multiply by a number to get rid of the fraction. Which one do you want to do? Okay, it's overwhelmingly you don't care. You can either add the 1/2 over here, or multiply everything by 2 to get rid of the fraction. Thank you for wanting to do something, people. Like that? Yeah. Okay, and then solve for a now. What are you going to get?
3 divided by negative 4. 3/4 negative 3/4.
Okay? And then plug that in here. What do you get for C? C is just going to be the opposite value, isn't it? So C is equal to positive 3/4. Let's plug everything in. So my A value again was negative 3/4 over x. My B is going to be plus negative 1/2 over x squared. The last one's going to be plus 3/4 over x minus 2. Now, we don't like fractions and fractions. Okay, this is not that hard. Okay, so on the top, what's on the bottom? So just put it on the bottom. That actually works like that. So for the second one, which one goes to the bottom? And the last one, what goes on the bottom?
4.
I love me some partial fractions. Love them. Alright, and then the last one for case 3. This one, some people don't like. They think this one's hard, and I'm like, no, it's not. Okay?
And I'm like, no, it's not.
I don't think this is hard. It's just been long.
They just make me laugh. I don't know.
I have not been trying to be funny all year.
I know, but that's what I'm saying. They just make me laugh.
You're an indirect comedian.
You know that like person that like isn't funny, but like just the things they say and how they say it makes it hilarious. And they don't know they're being funny, but you're like, yeah.
You start off with, you know that person that's not funny? And I'm like, yeah.
Not like that, not like that. Not trying to be funny.
I've heard that before. My students are like, you're funny. And I tell them, oh, if you were to see me on the streets, you would not think I'm funny at all. I'm only funny because everyone else in this building is boring. Not everybody,
I like to think
a general idea. Teachers in general are boring. Now, this building, I don't know everybody, so I couldn't really tell you that or not.
Have you ever like had it like or had a teacher like been around a teacher that tries to be boring and it's just like really tries to be funny and it's awkward. You know, and it's really quiet and you're like,
Let's just do the next problem. Let's go. So how does the again, I only want to factor the bottom because I need the top to be in this form. So how does the bottom factor? Okay. So here's this is the last case we're gonna do. I don't really want to do case 4. I think it's stupid. So we're just gonna do case 3. Because case 4 just repeats everything we just did. Okay, so for case 4, if you cannot factor any further, then this right here is going to have a special fraction. It's going to be very special, because it factors no more. So the first fraction is going to be easy. It's going to be a over x. Not a big deal. The second fraction, I always need to go 1 power lower on the top. Because for this one, this is a power 1, so 1 power lower would be no powers. This one's a power 2, so on the top I have to have a power 1. So I need to do cx plus d. You can just memorize that for all I care, if you're totally lost. So anytime one of your factors has a squared in it, you need to do cx plus d. Anytime, because if you just try it, why did I pick C before B? I don't know. Where'd B go? I don't know. Does it matter? Who cares? Who cares? I don't like B. Not this time around. No. I don't know. I'm just used to doing CX plus D for all of these. I just am. That's why. So again, anytime you have a factor on the bottom that has a squared, the top needs to be CX plus D or BX plus C or whatever. I don't really care, but this is the idea. We cool? Okay, so when I write this out, I'm going to get 2x squared minus x plus 4 equals a what? X squared plus 4 plus cx squared plus dx. Why on the one that takes the most work do they give me the least amount of room? Oh my god. Do I complain too much? Okay, good. I'm a reasonable complainer. Can you please say that to the microphone and I'll show this to my wife? Hi, honey, I'm a reasonable complainer.
That was like some like I'm trying to think of a character. Give me a second.
Okay, I distributed and organized at the same time. It wasn't that hard for me to do because there's only 4 terms. Okay? So it's ax squared plus 4a, let's put that in the back because it's a constant, plus cx squared plus dx. I just kind of rearranged it. So now, let's set up my x squared equation. What's my x squared equation going to be? 2 equals a plus c. What's my x equation going to be? -1 equals d. That's pretty easy. And then 4 equals 4a. So what does a equal? A equals 1. So what does c equal? So I have everything. I mean, that's why they didn't give me that much work. So my final answer is going to be 1 over x plus 1x minus 1. Do you need that 1 in front of that x? Wait, because d is minus 1. Alright. If you don't want to put that 1 there, you don't have to. I have marker, though, so you can see this, so I'm stuck with it. Alright, I feel like you're ready to do your own problems. I mean, these are the 3 cases. This is it. So, I mean, I'm going to look to see what the heck is supposed to be complicated about.
Where was the voodoo magic that you were talking about?
Well, I'm glad you think there's no voodoo magic, though. You know, it's the going from blue to red that people don't like. People don't like going from blue to red. They hate it. Is that a question or a yawn? You asked that question as the air conditioner was coming on.
That's hilarious. Yeah.
Alright, every other thing here, I'm not too worried about it. Okay, for example, thank you so much. For example, 5, I'm just going to talk about it real quick. This is not a partial fraction because the powers are the same. Right? So how can you make it so that the powers can be the same? Or not the same. Long division. See, all you need to do is long division and then boom, do the rest of the problem. Not that hard, I promise you. Not that hard. Okay? I'm going to kind of skip over that and we'll just kind of talk about them as you do your work problems. Okay? So, let me cancel this. Alright, well, oh, wait a minute. Don't forget to like my video, subscribe to my channel, comment any questions you may have below, share on social media. I'll stop doing this gag next week because it's not funny anymore.